And welcome to section 4.2, modeling with linear functions. Two objectives here. We're going to build linear models from a verbal description and model a set of data with a linear function. Let's get started. We will consider this scenario with the common flu a little bit later. Let us look at some of the ways that we can build linear models from verbal descriptions. Number one, identify changing quantities and then define variables to represent those quantities. When appropriate, sketch a picture or a coordinate system. It is very, very helpful. Number two, read the problem once, read the problem twice, as many times as it takes. Look for information that provides values for the variables or values for part of the functional model. One of the things to look for are slope or an initial value. Number three, read the problem one more time to make sure that you understand what we're trying to find, what we're trying to identify, solve, or interpret. Once you do that, go ahead and identify a path for the solution given the information. Often this will involve checking, tracking units, building a table, or even finding a formula for the function being used to model the problem. If you need to, write the formula for the function. Finally, solve or evaluate the function using the formula. Once all that is done, reflect on your answer. Make sure it makes perfect sense. Of course, check your work. On several occasions, especially in this section, we are given a word problem that includes two pairs of input and output values, or an order pair. We're going to take advantage of this to be able to compute a linear function to solve the problem. Here we go. Now back to that introduction problem. So consider the scenario. The number of people afflicted with the common cold in the winter months steadily decreased by 205 each year from 2005 until 2010. In 2005, 12,025 people were afflicted. The first thing I want to do is I want to find the linear function that models the number of people inflicted with the common cold. We're going to call that C as a function of the year, and we're going to designate that T. What do we do? Well, let's take a look at what is changing and let's label our variables. So we have two variables, T, the number of years starting at 2005, and C, the number of people with the common cold. So our function will actually be C of T. What other information do we have that can help us do this? Notice that the number of people afflicted with the common cold in the winter months steadily decreased by 205 each year. This is certainly a designation of slope. So it's very important. Let's write that up. So because I have found my slope, I can write down that m is equal to negative 205 per year. Why am I using negative? Oh yes, because it decreases by 205 each year. I see, per year. Oh, so I have my rise over run anyway. Excellent. I think we're ready to write everything. So we want y equals mx plus b, but in our function notation, given our variables, it's really c of t is equal to m times t plus b. Now remember, that b is the y-intercept. I don't have a couple of points here to guide me. So where am I going to find my b? What do you think? Oh, that's right. B is the y-intercept. That's where x is equal to 0. And in this case, is where t is equal to 0. So where do we actually start? You got it. In 2005, we have 12,025 people afflicted. Got it. So this must mean that my b is 12,025. Pay very close attention to how this was done. So finally, our formula is C of t is equal to negative 205 times t plus 12,025. Think about that. Now for the next part. I want to find a reasonable domain and range for the function c. What was domain again? Oh yes, all the input values. And what was the range? Oh, that's right, the set of all output values. Okay, now think about this. What are all the input values? Well, that must be t. So t must be years. Where did we start? That's right, 2005. How far do we go? 2010. Ah, got it. But the domain is not necessarily 2005 to 2010 because our t is the number of years starting at 2005. So 2005 is 0, which means that 2010 must be a 5. Let's write that up. In interval notation, I have written 0 to 5, including the 0, of course, because 2005, and including the 5 because of 2010. Now, what about the range? Well, that must be the output values given the input values. So for me to figure out the range, I have to let t be 0, figure out what that gives me, and then finally let t be 5 and figure out what that gives me, and then write a brand new interval notation. Get ahead of me. Let's do that. So we know the range is the number of people with the common cold. So I'm going to compute z of 0, which is negative 205 times 0 plus that 12,025. And the same thing with the 5 for the number of years. I'm going to substitute that as well. And if we calculate both of those, I get 11,000 and, of course, 12,025, which we can now write in interval notation. Let's take a look at the next two parts here. So if the function c is graphed, what I want to do is I want to find and interpret x and y intercept. Now, well, one of the things that we can do is we can certainly create a table of values to be able to find the x and y intercept, and we'll graph it. We'll make sure that it matches. Here we go. So here's our plan. I have t and I have c of t, just like if I would have x and y. If t is equal to 0, I'm going to find a value for c of t, and of course that's going to give me the y-intercept. And if I let the entire c of t be 0, and I try to find t, that's going to give me my x-intercept. Let's take a look at a graph and do this. So here's a graph of the function. C of t is equal to negative 205t plus 12,025. Notice the x-intercept right here happens to be at around 58.659 years. Remember, t is years. And the y-intercept is, of course, what we exactly expected it to be, and that is 12,025 when t is equal to 0. Let's write that up. Now let's move on to the next part. If the function c is graphed, as we have it here, find and interpret the slope of the function. Now we don't need to calculate the slope because we know what the slope is. The slope was negative 205. But what does that mean? We need to write a sentence on that. So the slope means that every year starting in 2005 until 2010, there was a decrease of 205 people afflicted by the common cold. How about that? Let's move on to the next two questions. When will the output reach 0? And in what year will the number of people be 9,700? Well, for number 28, when will the output reach 0? What are we looking for? That's right. We want c of t is equal to 0. Remember, t is time, but c happens to be the number of people afflicted with the common cold. So that means I need to solve this for t. All right, let's get started. Get ahead of me. The first thing I'll do here is I'll add negative 12,025 to both sides. And then I will divide by that negative 205. And that should give me t, but I still need to convert it to the appropriate years. Don't forget. When I solve for t, I get the familiar 58.7 from the graph that we had, but remember, I need to convert this back into years. Now, we know that we started at 2005, and now I need to add the 58 years, 58.7, to figure out what happens when will I actually reach zero. Now, of course, this gives me 2063.7, but really we're going to use 2063 because that's the actual year that we reach. So C of t will be 0 in the year 2063, well beyond our 2010. Now, what about the next part? In what year will the number of people be 9,700? Well, it looks like we have to do the same thing, but instead of having 0, C of t is 9,700. So once again, we're going to solve for t in this case. I will, of course, add negative 12,025 to both sides, and then, of course, divide by negative 205 like we did before. So if I do all that, I get t is equal to 12.2 years. Now, once again, just like number 28, I'm going to add 12.2 years to the 2005 to find our correct year. So we have 2005 plus my 12.2, which gives me 2017.2, and we'll keep it at 2017.